All right, so again, you just saw this chart on page 91. These are the 5 types of variables, all right? The 5 data types. Now, if you look up on the screen here, what I did, and this has nothing to do with that program earlier, but I put all of them up there. So num1 and num2 are both integers. In some languages, they're just called ints, all right? If I wanted to show pi, and I've got it here to, 5 decimal places, because I don't know it any more than that, but that would be a float, and in some languages it's called a double. All right, you'll learn about this more in other classes. It's not that important. Here, notice I've got 2 strings. The difference between them is not just the value, but is to show you that in JavaScript you can either put a string in single quotes or in double quotes. It doesn't matter. This is a Boolean. Booleans can only have a value of true or false. And not that you probably care, but it's named after some mathematician who's been dead for, I think, a long time, named George Boole. All right. Age, since I didn't give it a value, it's undefined. If I took fname, which had my name in it, and I set it to null, now it's a null. Those are the 5 kinds. That's what you've got to know. And when I said before that next semester, for example, that C# might have 30 different types, it's a little bit of it's a little misleading because half of those are different kind of number variables. And what's the difference? The range. All right. How big the number, how big of a number can you fit into there? We'll get into all that stuff in other classes. I don't want to waste time on it now. So here they talked about numbers and floating points. I just showed them to you. Here they talk about the script that goes through that stuff, and they show you some floating points. This is E notation. If you don't know what that is, that's a real small number. So 1E minus 18 would mean you'd have 0.17 zeros and then a 1. But it's such a small number, plus it's so easy when you do that to screw it up, that people typically put it in E notation like that. You're not going to have to worry about it. All right? We're not going to work with anything that's that big or that small. They do show you a chart here in the book that goes through a bunch of that stuff if you have an interest. All right. One thing, this is a good point here. The author mentions this, and it's on page 97 with his best practices. I may have told you this before already. I don't have any idea if I have or not, but I'm going to hit enter a few times. But if you do this, if I say this, var answer equals 0.1 plus, and I'm going to cheat here. That's 5. So I'm just going to put it down here just so you can all see this. 6, 7, 8, 9, 10. How many people believe that if I do that, the answer it's going to give me is 1.0? I mean, I would have raised my hand. 0.1, 1/10 and 1/10, but computers are so imprecise that you're probably going to get an answer, and answer will be equal to something like, maybe 0.99999996543 or something like that, or it'll be equal to 1.0000000. That should be a decimal in there. 1, 2, 3, 4, something like that, because computers can't keep things precisely in there. All right, why does that matter? Okay, if you were doing a loan amortization program, everybody know what a loan amortization program is? So you buy a house, you take out a 30-year loan. So the first several years in the house, you're paying almost total interest and very little principal. Towards the end of your loan, you're paying very little interest and almost total principal. But it's how much the loan amortizes or gets worth, etc. The reason I'm telling you that is those programs are typically written using whole numbers, not using decimals like this, because they're not exact. If a bank found out that, let's say it was a bank that had branches all over the country, and they were doing stuff, and they were doing this. So instead of collecting $1 from people, they were collecting this. All right, you might say, well, it's still $1. No, it's not. Because if you do that and you talk about millions of customers, it will come out to thousands, if not more, of dollars. All right. And again, if you don't think stuff like that actually happens, because I love telling this story, it was so great when I used to live. I lived out near Naperville, Illinois. They caught this guy. He was one of the toll booth collectors. And what he was doing was he was stealing money, but he was just stealing pennies and stuff at a time. He wasn't stealing a lot. But he had been working there over 20 years. And literally, when they went into this guy's house, everybody know what a pallet is, a wooden pallet? He had several wooden pallets that were stacked up with containers that held pennies. And he had hundreds of thousands of dollars in there because he was stealing it a little bit at a time. And nobody caught on. I don't know how they ever caught him. Right? That's the same kind of way in here. The reason that that's important is that's why when you calculate with whole numbers, because you want a more exact representation of the answer. All right? All right. Strings we already talked about. Again, single quotes or double quotes. These escape characters, you may or may not know about these, and you're going to see them in just a minute, but there is a chart in the book on page, I think it's 102, takes up most of the page. The one you're going to want to care about almost exclusively in here is this one, \n. Because and please when you do it, it's \. Everybody look at your keyboard. I don't care what kind of machine you have. You should have, towards the right-hand side of your keyboard, you should have an enter key there. If you look above the enter key, there should be a key that's got a pipe sign, and underneath it, it's got a \. Do you all see that? Don't use the /, because it means something else. All right, then they talk about using operators to build expressions. Again, we already talked about addition, subtraction, multiplication, division. I mentioned modulo to you. So I want to, for much of this time, I want to quickly mention what these are. This is the chart that's in your book that's on pages 104 and 105. Again, I'm going to go back to what I had here, hit enter a few more times so that all disappears. All right? I'm going to say this. var x equals 23. That has no meaning. I just made that up. Var y. Now, you all know this already. What's the value of y right now? Undefined, because we didn't give it a value. All right? So let's say what I want to do, let's not worry about y for right now, but let's say I want to add 1 to x. Does that make sense to everybody? I can do this. I'm going to show you 4 ways of doing this right now. 4 ways. I can say x equals x plus 1. It's one way. That's the way most people would do it. There is a shortcut that's built into this language. In most languages, I can say x plus equal 1. Notice how it's a little less typing? If I only want to add 1 or subtract 1, just 1, I can also do this, x plus plus, or I can say plus plus x. All 4 of those, so imagine I put any one of these. That's all going to make the value of x be 24. Does that make sense to everybody? And as you'd probably guess, if you haven't already, I've also got those. So that's how I can decrement. So this right here is called the postfix incrementer, the prefix incrementer. We're going to talk about the difference in just a minute. The post decrementer and the pre-decrementer. All right, so either increment or add 1 or decrement, meaning remove 1. All right, now I just want you to realize if I said I want to add 5 to x, everybody with me? I want to add 5 to x. Then there's only 2 ways I can do it. I can either say x equals x plus 5, or I can say x plus equal 5. I can't use the plus plus or the minus minus with anything other than 1. So I can't say x plus plus 5. The computer doesn't understand that. You'll get an error every time. All right? So not only is there a plus equal that I just showed you and a minus equal, but there are all these. So in other words, there is a plus equal, there is a minus equal, there is a times equal, there is a divide equal, and there is a modulo equal. They're all shortcut operators. When you are beginning your programmatic career, it's important that you understand what you're doing. If this makes more sense to you, I can guarantee you that you'll never see a programmer write that, a professional programmer. They will always write one of these, always, because it's less typing, all right? I've never encountered a student yet who said, yeah, I got into IT because I like to type, all right? And I do like to type, but not if I'm typing out code. If I can save myself a keystroke here and there, I will, all right? So they do mention all these incrementers and the decrementers, etc. Those are they're called the compound assignment operators. They're the second ones that are shown in that chart on page 104. Now, I mentioned, so what's the difference between these two? In this case, there's absolutely no difference. Everybody hear what I just said? In this case, there is absolutely no difference between these two and these two. So why is there ever going to be a difference? That's what I want to show you right now. So I want to grab that value again, and I want to paste it back in here. All right? Get rid of the comment. Now I'm going to say, oops, var y. Now what I want to show you is the difference between this, y equals x plus plus, and y equals plus plus x. Okay? Because now there is a difference. In both cases, this, we're still adding 1 to it, so it's still 24. This one is called the post increment. This one is called the pre-increment. So why am I telling you that? Because it has to do with when it adds. This right here, this line, so y equals x plus plus, that's the same thing as saying y equals x plus plus. So when you get done, it takes 23 and it assigns it to y, then it adds 1 to x. So when you get done, y is now 23 and x is now 24. Does that make sense? On the other hand, if I do this one, so that was that first one. If I do this one, the pre-increment, that one right there is like saying x plus plus, y equals x. So now both x is 24 and y is 24. See the difference? If that confuses you, don't use it. Or do it in 2 statements. I want this to make sense to you. There's a ton of operators and a ton of things like this that you could do to make your life easier. So why would you ever use something like that? Because it typically will make your program run faster. And if you are working on an application that's time dependent, anybody ever gone out to a site like Ticketmaster or any of those places to get tickets? A lot of times when you open it up, it tells you that your window is only open for like maybe 90 seconds. That stuff's all time dependent. So you're trying to figure out ways to save time any way you can. All right? If I'm writing a payroll program that runs every 2 weeks at midnight, who cares? It doesn't matter really. Whether it runs in 37 seconds or a minute and 37 seconds doesn't really matter. All right? Now, does that make sense? If I change those to minuses, can you understand that it just would be subtracting 1 instead of adding 1? All right? And again, if that confused you, there are examples in the book. All right? All right, then we've got comparisons. So let's take a look at those. Again, I'm just going to keep moving this thing down and down and down and down and down. All right. So I'm going to say here var x equal 10, like we did before, var y equal 15. Here's a real important thing. This is maybe the most important thing you had in this entire class. Don't ever do that. Believe it or not, that's true. That's always true. Single equal signs, we learned this the first day, means assign. All that says is, can I go in and assign 15 to x? I sure can. If you want to test for equality, you must use 2. Now that's not the same in every language, but that's how it is in this language, that's how it is in C#, that's how it is in Java. So get used to it. All right? Now I want to show you something else related to that this may or may not make sense. Okay? So I'm going to come back and put in these same variables that I put up here. and I'm going to add a new one. Var z equals 10. All right. I told you before that JavaScript in some ways is kind of a poor language. Guess what? Oh, we erase that. There's too much junk up here now. But the thing I just added was right here. This. This is, on most of the time, not x equal y, it should be z, sorry. Most of the time in JavaScript, that's going to be true. Even though that's a number and that's a string, JavaScript likes to compare apples and oranges, so it says, oh, you mean convert that to a 10. See what I'm saying? All right. If you want to compare values of different data types, like we're doing here, then you use 3 equal signs. All right, that means equality and identity. In other words, are they the same data type? Okay? Now, quite often you're going to use this. I used to not use it at all because I just hated it. For some reason, it just was against me to type in another equal sign. But I use it a lot now. All right. Then a lot of the other ones that are in here, believe it or not, you already know what these are. I'm asking you a question here. Look up on the screen if you would. Let's remove this, and we'll just put it right here. If is that true or false? It's not a trick. False. 10 is not greater than 15, right? Also false. Correct? True? Also true? That's all of them. Those are your comparison operators that you see that are on page 104. And not only is there that triple equal sign, but there's also this for not equal. All right? This is how you check for equality. And this, just so you see this, because I want to be complete here, if I want to check for inequality, I do that. Now, depending on your background, some people will call that, they say it looks like a baseball bat, what's in blue right there. So they'll call that bat equals. From the land of Unix and Linux, they call it bang. So you sometimes refer to that, you hear that referred to as bat equals or bang equals, just in case you ever hear that. All right. There's other operators in here that are called logical operators. All right. Well, let's quickly take a look at those. Let's leave what we had here, the x and the y. I'm going to remove the z for now. All right. So I'm gonna do this. I'm gonna change this to I'm gonna make that 21, and I'm gonna make that equal to AWD. All right. This is the way I typically explain this. You may or may not like the explanation. I don't know. Well, let's say that I decide that at the end of the semester, I'm going to have a Christmas party. And if you want to go to that Christmas party, you have to meet 2 criteria. Okay? You have to be 21 years of age or greater, and you have to be in the AWD program. You have to meet both criteria. Does that make sense? All right. If both of those things have to be met, then I could have said, rather than x and y, I could have said something like if age, let's just say I called it age, greater than or equal to 21, and I use 2 ampersands to mean and program equal to AWD. Oops. So both of those would have to be true. Does that make sense? All right. So let's change this to age. And we'll change this to program. So both of those criteria must be true. If either you're less than 21 or you're in another program, you can't come to the party. Does that make sense? That's the good news. All right. Give you a really quick little thing. Charles, and some of you know Charles, he's the IT division head and he teaches in the other program there. His kids are really involved in Boy Scouts. Okay? And they did a thing this weekend where they made pizzas. And I don't know if they make them for themselves to sell them or what. But the point is, one of the fathers said, oh, I work for this restaurant business, and I can get you, what kind you want to make. He said, just something simple. He goes, I can get you pepperoni. Okay? So, good. So the guy comes with a 50-pound bag of pepperoni for these kids who want to make like 4 pizzas. I don't know of any pizza that has that much on it. So guess what we all got yesterday? All right, we all got pizzas. All right? So what does this have to do with anything? Well, let's suppose that I'm going to make pizza with all that pepperoni that I've got. And I've got way too much for 9 of you. All right? It just doesn't make any sense. But then Evan calls me and he says, well, geez, the people who, the people from here are in the same program, but the program is IWT. Could they come too, type of an idea. Well, I don't know. But then let's just suppose, and I believe you're all over 21, but let's say that Amin says, no, I'm 20, okay? He can't come to the party, correct? Right now with these criteria, he can't come. But if I change this from 2 ampersands to 2 pipe signs, that means or. That means if either of the criteria are true, or they're both true. So now, anyone who's over 21 can come to the party, or you can come to the party if you're in the AWD program, whether you're 21 or older doesn't matter. Does that make sense? What you'll see sometimes, and if you take a math class in it, you might see something like this, where you'll see X, Y, and then like answer. And this is called a truth table. So if this is 0 and this is 0, that's 0. If this is 0 and that's 1, then this is 0. We'll put here and put here or. So that would also be 0, 0, 1, 1. Now that might not make any sense to you, but what it says is we're comparing 2 things. If you're doing an and, if either one of them or both of them are 0, the whole thing is 0. It's false. All right? If you're doing an or, if any of them are 1, then the whole thing is 1. All right? So when or is less exclusive. All right? Some of you may have had problems with it. I won't lie to you. This is one of the problems that the person who's not here anymore had, was the whole thing about hair, etc. All right, type of thing. But it's not that, well, we can let it slide. We can say, yeah, we've got all these requirements, but you can do this or you can do that. That's not what business and industry want. They want ands. So we've looked at now and we've looked at or. All right. Would you agree that this is more, or I should say, less inclusive? And this is more inclusive. Does that make sense when I'm saying inclusive? Does that make sense to people? The only other one that's in there is something that's called not. And not is real simple. All right, so the and, put this back up here. That's and with the 2 ampersands. Okay. That's or with the 2 pipe signs, and not is called an inverter. It's just an exclamation point. So if I do this, if I say var married equal true, okay? I can write down if married. And that's a shortcut for saying if married equal true. Does that make sense to everybody? That's a shortcut. If it doesn't make sense, you can still use this, but it's more typing. All right? This is a shortcut for this. Does that make sense? All right. So if you say to somebody not married, it's the same thing as saying single. You say to somebody not single, it's the same thing as saying married. That makes sense? So the not is called an inverter, and that is at the top of the list. Again, it typically is referred to as an inverter. It makes true false and it makes false true. The reason I put it up there on the board, and I put it in that order, is I can have really long expressions. So what if I decide I don't want single people at the party? So I could say, if not single and greater than 21, or, etc. So you can combine ands and nots. When you combine ands and nots, you do the nots first, then you do the ands, then you do the ors. If you want to change the order of precedence, how do you do it? What do you use? Parentheses. But if you don't, by default, you will do the nots, then the ands, then the ors, because the not is the most exclusive. And if you say, I still don't get that not, it's like making something negative. Basically, that's what it's doing. All right. So again, all this stuff is in the book. I'm just trying to give you some of that stuff. Now this string, and there's so many more string operators than what are shown in the book here. Some of them are shown, in the book, but you'll see them in later chapters. Okay, but there's a lot. And if you remember, because Brady was good enough to find that archive site for me, that thing on Hunlock, but you can even go out to W3 schools, and you can bring up JavaScript string functions. All right, and there will be probably at least somewhere around 50 of them. Okay. All right. They mentioned binary and unary. Well, guess what? We just looked at what those were. This is, if I say, if I show you this one right, let's see, I'll do it like this. Y equals X plus Z. Addition is what's called a binary operator. You need something on both sides of the plus sign, otherwise it doesn't make sense. But if I do this, tell me, I'm asking you this question, is this legal in a computer programming language? I typically would say var age equal 21. But do you think I can do this? The answer is yeah. It already is positive, but I can do that. Now, that's a unary operator because it only has one thing. The things on the other side, this is the operator, that's the operator. These are known as operands. All right? And again, that's shown in your book. They explain that to you in the book. Is it that important? No. All right. Arithmetic operators, we've already looked at these. And again, they have you use some of those in this photographic example that you work on in the chapter. We already looked at plus, plus, minus, minus, and I talked about negation, so that's all explained in here. They do mention in here that they talk about code being self-documenting. Well, one thing that I'm forcing you to do is you're going to have to start using good variable names from the get-go. All right, that makes your program more self-documenting. All right, and if you don't understand what I mean, you will as we go on. Assignment operator, I mentioned that's a single equal sign. We looked at the plus equals, so if you turn up to page 113, that's where the chart is, but we already looked at equals, plus equals, minus equals, times equals, divide equals, and modulo equals. So you've already seen those. Okay. On page 113, and I already buzzed by it quickly, but again, you're going to see this again and again and again. This NaN for not a number. Okay? Bottom of page 113. On page 116. Again, I'm just trying to introduce this stuff to you. This right there, that's one of the more powerful things that exist in HTML. If you use inner HTML, you can write anything you want on a web page in virtually any place you want to write it. We'll end up doing that later on. All right? When we talk, there'll be a chapter in here later that's on the document object model, chapter 5 or something like that, but that's page 116. So this is what we looked at. I already showed you some examples. They call it strict equal there and strict not equal. I usually hear it called identity equality or identity inequality, but you know, either way is fine. But we went through some examples of those. This is the note that's up here is pretty good on the top of page 119. It just explains what I explained to you already. All right. On the bottom of page 119, I'm going to show you this example in code right now. And this is, I don't know, I never understand why people don't like this operator, because it can really save you a lot of time. So let's imagine here I've got int x equal 23, int y equals 15, oops, and int, I'm going to call this min, and I'm not going to give it a value, okay? So its value is undefined. You all know that. And I'm going to say if x is less than or equal to y, min equals x. Else. Now we haven't talked about if statements yet, but hopefully I'm doing something simple enough that it makes sense to you. Does that make sense, taking a look at that? What's on the screen right there? Okay, it's saying if x, which is 23, so if 23 is less than or equal to 15, then the minimum is going to be 23. It's not, so the minimum is going to be y, so min is going to be 15. Does all that make sense? Okay, I can rewrite that in one line. All this, I can rewrite that in one line of code. That's what I'm going to do right now. All right, so I say here, I'm going to put it in as a comment, but so I'm going to say here, min equals x less than or equal to y, question mark x, colon, y. Now that might look really ugly to you, but it actually makes a lot of sense when you look at it. What this says is check and see, do this first because it's in parentheses. If x is less than or equal to y, if it's true, what comes after the question mark means true, take x and assign it to min. If it's false, which is what this does, then take y and assign it to min. So you see what's happening in there? All right. Again, if it confuses you, then don't use it. I was at a meeting with a bunch of teachers once, and one of the teachers got up and said, I want to know how many people use this. And it was funny because I raised my hand and a couple other people did, and he said, I don't really see the need for it. Well, I just showed you where I think is the need for it. All right. And again, you're going to see examples like this again in Java. Not JavaScript, but in Java. C# also. Okay. So again, there's a bunch of stuff here on 120, 121, and 122 where they're just going through this photography example. What they do mention, and again, I'm just trying to hit you with some wordage here. Now, I don't know why they decided to do this. It's also going to be on your test. But they talk about things being truthy or being falsy. It's not just this language. Other languages use this terminology. So falsy is, notice what it is. It's the empty string, it's -0, it's +0, and it's NaN for not a number in this language. Everything else is referred to as truthy. And why do truthy and falsy, I know it sounds stupid, but why do they matter? because everything that you put in here, in those parentheses, has to be true or false. So if it's a truthy value, you do this. If it's a falsy value, you do this. All right, I wish they'd use better names, especially considering that one of those terms has bad terminology or a bad context associated with it. All right. But they do talk about it here. They talk about falsy on the bottom of 122, and they talk about truthy on the top of page 123. All right. So truthy is anything that's not one of these. If it's not one of those, it's truthy. Okay. All right, logical operators, I just went through those with you. So that's the and, the or, and the not. So if you rather look at it the way they explain it in the book, hey, that's fine with me. I just want you to understand it. It's not that it's important that you have to understand it because I explain it that way. I don't care. I just want it to make sense to you. All right? And again, the author puts lots of examples in here. And if you were ever asked, and I don't think it's on the test, but if you were ever asked, if it's not on this test, it might be on one in one of the other classes. All right? And I guess I erased it. No. Yeah, I did. Not and or. You do nots first, then you do ands, then you do ors, unless you use parentheses. All right, so that's the order of precedence. There's also some extra operators that are in here. For right now, we're going to go over arrays in a later chapter, so don't worry about those. All right. I do want you to understand something, and that is, I don't want to show you code, I just want to show you this. That if I write something like this, I should always write like var age equal 21, okay? But some programmers are just very lazy. So they just start typing in age and they say equal to something or whatever. That's bad. But what I want you to understand is as far as JavaScript is concerned, don't even worry about the var for right now or setting it equal. But to JavaScript, this is a variable. Variable. This is a function. If I said, what's the difference? You all can tell me what the difference is. That's the only difference that JavaScript sees too. It has nothing to do with capitalization or anything else. If you have parens associated with something, it's a function or a method. If there are no parens, it's a variable. All right, and you have to remember that. I've seen people do that before. My function isn't working, and they didn't put any parens in. Well, I don't need any parens. It doesn't take any arguments. It doesn't matter. All right. You might understand that, but the computer does not understand that. This stuff with objects, that's going to be in a later chapter, so I'm not going to hit that now. The operator precedence is shown on page 127 in the chart right here. For now, just be concerned with the ones that we've talked about. All right? And there's nothing on the test that says, hey, you've got to memorize this. And you go, well, that's not too bad. Yeah, but it's continued on the next page. Because there's more. All right? And they do give you some examples, and they show it with and without parentheses on pages 128, 129, 130, 131, and 132. All right? All right, that was a lot to get through. It wasn't that long. It was only 38 minutes. All right, but I think I'm going to give you another break now. But just one thing before we do. Man, I got to find out where the heck I have those. Oh, I know where they are. Let's see. Is we're going to, after the break, we're going to go through. The test review for Chapter 2. So if you have that piece of paper with you, all right, make sure you get it out. It's 5 minutes too, so let's come back, please. Let's just make it 5 minutes after. Let's take 10 now. We can do this by 10:30. Okay? If everybody, I'm going to start right when the little clock here turns to 10:10.